Okay, this is going to be a description of the assembly of the Arduino prototyping shield and how to interface that with an Arduino module. First comment, I'm working on an ESD mat with a ground strap, and that's grounded back to the earth ground. The prototype board is not ESD sensitive. Processors may be, and I'd rather not kill one if I don't need to. What I want to do is assemble the boards. I want to solder the prototyping board to the Arduino. So the first thing I'm going to do is use one of the barrier strips. Use a barrier strip, plug that in, cut it off at the end of the connector, and then I'm going to do that same thing to fill all the rest of the holes. Long side of the connector is down. Now I'm ready to actually connect the prototyping shield to it, and I'm simply lining those two up. And once I solder that in place, that's going to hold those pins in a fixed location. I'm not actually going to solder it, but if I were, typically what I would do would be to come down, solder the end, the first and the last pins on each one of those 4 connectors, or 6 on the Mega board. This is actually the prototyping shield for the Mega. It's got the same footprint as the Uno. It just has an extra 4 connectors on the end there. On the Mega, potentially on the outside edge, what you can do is just use 2 of the barrier strips like that, and that's the easiest way because you've got a lot more pins on the Mega. But that's what that does. Now, if I'd actually soldered that down, what I'm going to do is get that out of the way. I'm actually going to use another board that's been used for other projects. I don't have to waste one of those. So that board, again, mates very gracefully. And if I take an IC socket, first comment is on the sockets, there's typically a notch. On the driver chips, you'll have the notch on the top. Pin 1 on the left, pin 16 on the right, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 through 16 on the other side. So at the moment I'm going to leave that back into the tube just because those are likely ESD sensitive. They certainly come in the ESD bag. Now what I want to do is I'm going to position the IC. What I want to do is find some place on the board so I'm not shorting to underneath it. So let me pick that particular location just to get, for what I'm doing here, it's fine. What I'm going to do is solder from pin 3 to the driver circuit. Question, where am I going? These are the pin configurations, the ULN 2003s. The inputs on pin 1, corresponding output on 16, input 2 to output 2, and so forth. So they go straight across, so it's a nice easy chip to deal with. Pin 1 will be on the left-hand side when we're looking at it. When I turn it over, pin 1's now going to be on the right-hand side. I'm going to sit it on something so that those pins will be sticking out. So once I can find a pin on the IC, I'm going to go ahead and put just a tack of solder. I want to make sure, yes, that's held that IC in place. And then I'm going to grab the other corner just to make sure it doesn't go anyplace. So I now got the socket held in place. Now I'm going to be using 2 kinds of wire. One is a 30 gauge solid core wire wrapping wire. And I'm using it because it's easier to deal with the solid core wire. Because when you bend it, there's only one strand. When you bend it, it kind of stays bent. I'm going to take about 1/4 inch. Use a wire, this is the wire stripper from Wire Wrapping Tool. So I've now got, I didn't get that stripped. I've now got the stripped wire, which you may not be able to see. What I'm going to want to do, if I'm going to pin 3, I'm coming on the hole, it's marked pin 3. I'm just going to kind of give that a fair amount of slack. And that actually was a little bit long. What I'm going to do is take a pair of tweezers and wrap that into a nice little horseshoe shape. I'm going to throw a little bit of solder on pin 3. Now, whichever driver circuit I need to deal with. So I've now got a little bit of molten solder on there. I'm going to lay that down. And what I want to do on that guy is make sure that the end of the wire is kind of over the pad, because I'm going to have, potentially you're going to have a bunch of adjacent pins. And the nice thing about the fine gauge wire wrap wire, you can get those in, maintain a clean contact between, because you really don't want to short between them. And I'm just going to pull that through from the back side, so I've got the wire there. Now what I want to do, I'm going to pull that wire up. I want to go to pin 1 here. So when I turn it over, it's going to be on the right. So I'm going to give myself a little bit of slack. Cut the wire. Again, cut off a little bit. Strip it. And I'm going to come back in with the tweezers to make the bend. Pin 1 is in fact still on the right hand side. Now it's a little bit trickier to hold that in place, but anybody who's told you, who's ever learned how to solder, knows you heat the work, not the solder, and I'm going to cheat and do that backwards. I'm going to actually accumulate some wire on the run just because I'm trying to do this with one hand. Hold the wire in place. Melt the solder onto it. I've now got the wire junction there. I want to kind of pull that to the side and make sure, hopefully the end of that wire is all just over the pad, so I don't have any shorting to the adjacent pads. On 1/10 centers, you've got not much room to play with around the edges. So that now gives me the signal connection between pin 3 out of the process. Actually, when it's mated, that will give me the connection from pin 3 through the feed through the solder joint, through the wire to pin 1. Now what I want to do is come out of pin 1 to the motor drive channel. Here's where things change a little bit. In this case, what I'm using is it's actually the cheapest wire I could find on Amazon. So it's fairly nice. It's a 26 gauge, so it's a fairly small wire gauge. It's not moving a whole lot of current. And it's a very soft insulation, and it's a tinned copper wire, so it should be a reasonable wire. Now what I want to do is that these can be tricky to strip, this one. The 26 gauge, so I'm using a wire stripper to get there. I'm going to strip probably about the same 1/4 inch I was earlier. I'm going to kind of grab that, twist it. This is going to be a bunch of very fine strands, and I want to keep them separate as much as I can. I'll put that in a little vise. Just heat the end of the wire. Use solder, not wire. Heat the end of the wire. So that just tins the end of it, and I want to make sure that it's smooth all the way out. So now what I've got is the wire, and if you pull on the end of the wire here, you obviously notice it'll strip back quite a ways, and I'm going to take advantage of that. So now what I want to do is connect. So we look at the schematic. I've got the input connected. I want to go to the output. So pin 16 would be straight across from pin 1. Now again, I got to be careful that I don't short to the neighbors. So I fed that through. Pin 16 is the right, I'm in the adjacent pin. Put the end of the wire through. I'm then going to grab that, kind of pull it tight so the insulation is compressed. Wrap that around the pin. Do that so I don't bend the pin over. Push that down flush and hold it. Now what I want to do is come back in and solder the end of that guy. I'm going to have a little bit of stray wire on the end of that. I'll cut that off in a second. Okay. So that should give me the output wire. Wire cutter, cut off the excess of that. And then what I kind of want to do is go back in and just give that a squeeze. What I want to make sure is that wire again does not short to its neighbors. Otherwise, I'm going to have a short between motor channels. So now I'm ready to connect that to the motors. And for these motors, the yellow is the hot. So that potentially if I'm connected to the white channel, that'd be one of the 4 phases. And so I then would cut that wire off. And typically I'd use a wire nut or some other technique. I'd solder that, but it'd be a little bit faster and easier just to cut it off, strip them, and use a wire nut on the end of the motor. That way you can get whatever length you need to get to the motor, whichever motor's located. And so when you're done with the board, you'll actually end up with like 32 of these wires hanging in space. Power will come in out of this power supply into one side of the motor, through one of the motor phases, down through this wire, through the driver, and it's actually going to pick up a ground path off pin 8. If you look at the driver package, pin 8 is the ground connection. So what I now want to do, I want a little bit higher capacity current, so I'm actually going to be driving up to 7 of these motor channels per driver set. So what I'm going to use, this is a 22 gauge wire, unlike the 26 gauge here. So it's a little bit heavier, it's a little bit more current capacity. Same kind of thing though. I'm going to take the end of it, twist it, try and keep all the strands together. The extraneous strands are frequently will cause a short someplace. Again, I'm going to heat the end of that, tin it to keep it together. Now I want to come in, pin 8 is on the bottom left here. And I got a bit of a, not totally smooth, so I'm going to push off a little bit. And now we'll go through the hole. Again, I'm going to grab it, pull at it, pull at it. And the ends are a little bit easier because you don't have the other pins you're dealing with. So I'm going to wrap that guy around, press it down flat, bend it flat to the board. So now it should be ready to solder. Take the soldering iron. Okay, so now I've got the signal path. We'll take, from one end side of the power supply, the computer will control which one of the motor phases is running. So the motor will control which phase when, so it turns the motor forward or backwards and so forth. Now when I get ready to actually install the chip, typically you can push it in on one side, use your finger to wedge it in on the other. That one went in fairly easy. If you happen to have an insertion tool, a little bit easier and more reliable with that. That one went in since I've used it before. So now I would be ready to plug that in. Negative side of the power supply, motor return. So I've now actually got the first of up to 32 channels for an 8 motor circuit card. And that would give me the basic drives. Now, the only other thing I would need to do is handle the switch controls, the advance button. So again, I take another, same way I did the return, take that same small gauge wire, strip, tin, feed it through pin 13 and the ground. Take those 2 wires, to a 1/4 inch phono jack, That then connects, and I would use that for the foot switch. That typically gives me all the electronics. Now that board would plug into the processor board, kind of align the two D ends. Like I say, the Mega would work the same way. This is just a little bit smaller and easier to demonstrate with. When you're running, the power to the motor would come out of the external power supply. The computer would actually feed power to the Arduino and the control signals. And so the computer will tell it what to do. The drivers will close. The motor phases will run. And that typically is what it takes to do it. Okay, let me talk about the actual assembly into the Dobby head itself. In this particular case, I'm looking down on the board with all 32 drivers. Motors 1, 3, 5, 7 are on the left, the other ones are on the right. The wire bundle coming in from this side is to the right, the bundle here. What I've done is actually sleeved the 6 wires from each one of the motors and labeled them so I can tell them all apart. And then if we look through the Arduino here, the ground and pin 13 here come over to the foot switch. There's no connections down through down through pin 0. Be a little bit careful. You'll notice the routing on pin 14 here. Pin 14 to the processor is actually down here. So I've come the wire out of that hole to pin 14, 15, 16, 17, 18, 19, so forth. So the first 2 motors I did in white wire. The next ones are all in the yellow. So there's 2 motors. There's the remaining 6 motors. So that takes care of the 32 wires that actually control the motors. And if I look back over at the other side, there's nothing on most of these guys. I didn't even use a connector on that one. Nothing on the analog inputs. The only other wire that's connected is the ground line here. And the ground line here I had not talked about previously actually connects to the ground on each one of the driver packages. These are the drivers here. And you can see the black bundle here is off pin 8 on each one of those. Those 8 wires come together, come into the black wire here, which comes from the negative side of the power supply connection. The positive side of the power supply connection comes in. I split that kind of into the left and the right feeds. Each one of those then fans out into another wire bundle that feeds to the yellow and white wires. So the positive side goes into the wire pairs for each coil on the 4 motors on the right and the 4 motors on the left. So that gives me the signal paths, and then the other thing I've done is just wire wrap those guys together so that they don't it'll be easier to manage. So that gives you a pretty good look at the top of it. The Mega 2560 is underneath the prototyping card. These guys are real stiff because of the number of pins on them. What I'm going to use is a small pair of needle nose. And I'm just going to use them to force the board apart a little bit. You don't want to push too hard. You don't want to break a trace on the board. Okay, so I've now got it loose enough I can get to it. So I can see the processor underneath. The USB connector on the processor actually just goes straight back out, and that's what connects from the outside world. The other side of the board, I can see the motor feeds coming off the driver packages here. The yellow and white wires are all the connections from the digital driver pins into the driver ICs. And then the only other wire here is the one blue wire is the ground line that comes across and connects to the black pin 8 on the first driver. And that should give me, and that gives me all of the wiring on that daughter card. I'm going to line it back up, push it down again, and now that basically should be alive and kicking and ready to go. Okay, let me talk for a couple of minutes about the particular stepper motors. The motors I have in hand are a Type 42BYG H404. These guys are a 6-wire motor. I don't necessarily trust ordering the same part. I'm going to get the same thing each time over a long period of time. I'd buy all your motors at the same time to make sure you get the same thing. Now the question is which wires control what. The basic configuration of the motor is there's going to be 2 coils. One coil effectively controls up and down, the other one left and right. So when the motor steps, I would sequence it. I would throw the up, and then upright, and then right, and then down right, and then down, and cycle through. As I keep going, the motor will actually take a lot of steps to get one rotation, so I have a lot of resolution. But the ambiguous question is which wire is the common and which wires are the outside edges. So I'm going to use a voltmeter here, and if I look across two coils versus one coil, I'm going to see twice as much resistance. So I'm actually just kind of randomly grab a wire here. With the 6-wire motors, the two coils are electrically independent. And then what I would do would be to connect the two commons together. But I don't know which one's the common yet, making that assumption. So I'm sitting on the green wire. Green to blue, I don't see anything. Green to red, I don't see anything. Green to white, I don't see anything. Green to yellow, okay, I've got 30 ohms. And then green to black, I've got 60 ohms. So if I get 60 ohms to black, that tells me I'm looking across two. So the 30 ohms tells me where the common is. So I know the yellow, so that gives me one side of the motor. I don't know whether that's the up, down, or left, right, but it doesn't really matter. So now I'm going to do that same thing again on the other wires. Once I determine that the white, what I'm actually going to do when I connected is connect the white and yellow together, and then the 4 poles would be the black, red, green, and blue. And so eventually I would associate that. If I have a 5-wire motor, similar thing, only what's here is the yellow and white wires on that motor would be together. If I just measure across one of the wires, the one with the lowest resistance would tell me where the center conductor is. Now, on the other hand, if I have this, I know the opposite poles. And when I connect the pins, I can get there directly. With 5-wire, there's a little bit more risk. Now, there's a couple other things. If you make a mistake, you can potentially go back in and change the wire. You risk damaging the board in the process of doing that. The other thing you can do is change the software that tells it where the pins are. There are a couple of arrays that are useful. In the software, there's a motor pin array that says for each one of the 4 motors, which of the 4 wires connect. It assumes it's up, right, down, left. And so if you find 2 pins are reversed, all you do is switch. If you want to reverse the motor direction, pin like 1 and 3 or 2 and 4, both would reverse the motor spin. You'll notice the motors, in that array, the motors on the left have a different pin sequence than the motors on the right, because the shaft runs the same direction, but the motors are on opposite sides, so they turn different directions to get the same space. So if I had a pin change, if I have an order I need to change, changing it there is a lot safer and easier. The other question is going to be, how fast can I turn the motor? And the motor delay, basically that's how I'd slow the motor down to make sure that I'm catching every cycle. If it's moving too fast, you'll find under load, it won't go all the way up. When it comes down, it looks like it bounces because it'll catch all the down cycles, but not the ups. I'm using tape in here to increase the diameter of these rods, and that will change the number of cycles it takes to get back up. And the other thing I would be inclined to do if I were really playing with this, I would come back in with a heat shrink over that tape to hold it in place. And then this shaft up variable would need to change to tell it how many rotations of the motor. And then the other question would be the pin indication. That would be pin 13 for the advance button. And that pretty much walks me through all of the connections on it. All right,